Hey there. Tonight we're visiting the worst address in the solar system, and it's hiding behind the most beautiful light in your evening sky. Right now, if the sun has just gone down where you are, there's a good chance you can see it. One brilliant point above the horizon, brighter than any star, steady and calm and almost gentle. People wish on it. People fall in love under it. And here's what nobody tells you while you're looking at it. That soft silver light is coming off a world where the ground is hot enough to melt lead, where the air presses down like 900 meters of ocean, and where the clouds are made of acid and the rain has never once reached the ground. It's the closest planet to Earth. It's almost exactly the same size, built from the same rock and the same iron, and for 3 centuries astronomers called it our twin. But here's the part that stopped me when I first read it. Venus is the hottest world in the solar system, hotter than Mercury. Even though Mercury sits nearly twice as close to the sun day, its day lasts longer than its year. Its mountaintops are frosted with metal, and the toughest machine humanity has ever built lasted down there for 127 minutes before the planet killed it. So how does a twin of Earth go that wrong? What happened to the ocean it was almost certainly born with? And why do a number of very serious scientists believe that 50 kilometers above that furnace floats the single most comfortable spot in the solar system outside of Earth itself? That's where we're going tonight, one gentle layer at a time, from the light in your window all the way down to that hidden floor, and then back up into the clouds where a human city could genuinely drift. If these journeys help you rest, a like or a subscribe is the kindest way to say so, and leave a comment telling me where in the world you're drifting off from. It's always bedtime somewhere. For now, dim the lights and settle in. I'll keep watch. Now, you're floating above a bright white world with no features at all, and we're going down together. Let's begin. Let's start with the light. Because the light is where the deception begins, and because it's the only part of this planet most people will ever see with their own eyes. Go outside after sunset on almost any clear evening this year and look toward the west. If there's a single point of light hanging above the horizon that's obviously immediately brighter than everything else in the sky, you're looking at Venus. You will not need a chart. You will not need to know where to look. It announces itself. Nothing else in the night behaves that way. Here is how bright that actually is, stated in numbers rather than impressions. Venus is the 3rd brightest natural object in the entire sky. Only the sun and the moon beat it. At its most brilliant, it is roughly 15 times brighter than Sirius, and Sirius is the brightest true star in the night. On a genuinely dark night, far from any town, Venus is bright enough to cast a shadow. A faint one, but a real one. An edge of your own silhouette laid on a pale wall by the light of another planet. And if the air is very clean and you know precisely where to look, you can find it in broad daylight, a small, hard white point sitting in an ordinary blue afternoon sky, the only planet that doesn't bother waiting for dark. That brightness has one more consequence, and it is a slightly comic one. Venus is, by a wide margin, the single most reported unidentified flying object in human history. It hangs low and blazing in the twilight. It shimmers through the thick air near the horizon. It appears to dart when the eye jitters, and every year thousands of entirely reasonable people conclude that it must be a craft of some kind. Pilots have chased it. In 1966, police officers pursued it across 2 American states in their patrol cars, convinced they were following something that was following them. Even a future president of the United States filed a formal report of a strange object that investigators later concluded was almost certainly Venus, doing what Venus does. No other world in the sky is routinely mistaken for a visitor. So hold on to that image, because everything that follows gets measured against it. A calm, beautiful, unmistakable light. The one object in the night sky that everybody has already seen, whether they knew it or not. and everybody always has. This is worth a moment, because no other planet has been watched so carefully for so long by people who had no idea what they were watching. Venus appears in the sky in two roles, and for a long stretch of human history, nobody realized they were the same object. Because the planet orbits closer to the Sun than we do, it never wanders far from the Sun in our sky. It can only ever appear shortly after sunset, or shortly before sunrise. It is never overhead at midnight. It rises as a brilliant point above the western horizon, climbs, and then falls back into the solar glare, and some weeks later reappears on the other side, before dawn. The Greeks, who were careful observers, took those two appearances for two separate bodies. They called the morning one Phosphorus, the light bringer, and the evening one Hesperus, and they were regarded as different things entirely. Others worked it out. The Maya built one of the most precise astronomical traditions in the ancient world around this planet, and the surviving tables track its cycle with an accuracy that holds up over centuries. They knew exactly where it would be, and when, generations in advance, and there is a lovely piece of geometry hidden in that cycle. The full round trip, from brightest evening star back to brightest evening star, takes about 584 days. Run that cycle 5 times, and it comes out almost exactly equal to 8 Earth years. So the positions repeat, generation after generation, tracing the same 5-pointed figure against the background stars, close enough to perfect that people noticed the pattern long before anyone could explain it. Then, in 1610, Galileo turned the first astronomical telescope toward that light and saw something forbidden. Venus had phases. It was a crescent, then a half, then a fat gibbous shape, then a small full disk, exactly like the moon, and crucially it was largest when it was a thin crescent and smallest when it was full. That combination is impossible if Venus circles the Earth. It is precisely what you would expect if Venus circles the Sun, sometimes passing between us and it, sometimes running around the far side. He had found direct visual evidence that not everything goes around us, and he knew exactly how dangerous the observation was, and he first published it as a scrambled Latin anagram so that he could prove priority later without yet committing himself in public. The blank white light in the evening sky quietly helped to overthrow the cosmos. Now, why is it so bright? This is where the trouble starts, because the answer is not what people assume. Venus is not bright because it is close, and it is not bright because it is large. Venus is bright because it is covered. The planet is wrapped in a complete, unbroken shell of pale cloud, and that cloud is an extraordinary mirror. It reflects roughly 3/4 of all the sunlight that falls on it. Compare that with the worlds you know. Earth reflects about 1/3. The moon, which looks so brilliant when it's full that it can wash the stars out of half the sky, reflects barely more than 1/10 of the light that hits it. The moon is, in truth, one of the darker objects in the inner solar system, roughly as reflective as a worn asphalt road. It looks bright to us only because it is close. Venus is not like that. Venus is a mirror the size of the Earth, and a mirror shows you nothing. That is the entire point of a mirror. When you look at Venus, you are not seeing a surface, or a landscape, or a world. You are seeing sunlight bouncing off the top of a cloud deck, and the light never reached the ground at all. Every telescope ever built and pointed at that planet for 3.5 centuries saw exactly the same thing. A blank, beautiful, featureless face. Not a mountain, not a coastline, not one permanent marking that anyone could name, and then find again the following week. And it's worth sitting with how strange that is, because it made Venus unique among all the worlds our ancestors could see. Every other bright object in the sky gave the eye something to hold. The moon has its dark seas and its bright highlands, and every human culture that ever looked up drew pictures in them. Mars has polar caps that grow and shrink, and dark markings that shift with the seasons. And by the late 1800s, people were mapping canals onto it and populating it with dying civilizations. Jupiter has belts and a red spot. Saturn has rings. Venus offered a blank screen. A perfectly smooth, perfectly bright, perfectly empty surface for the human imagination to project onto. And for 3 centuries, that is exactly what happened. The logic that filled that screen was not stupid. It was careful, and it was reasonable, and it was completely wrong, which is a combination worth paying attention to. It went like this. Venus is nearer to the sun than we are, so it must be warmer. It is permanently covered in cloud, and cloud, in every human experience, means water. Warmth plus water plus a perpetual overcast sounds like something specific to anyone who has ever stood in one. It sounds like the tropics. So that is what they built. In the early 20th century, one of the most respected scientists alive, the Swedish chemist Svante Arrhenius, a Nobel laureate, wrote seriously about the conditions beneath the clouds of Venus and described a hot, wet, dripping world of swamps, rank vegetation, and constant humidity. A planet, in his description, in a stage of development resembling our own Carboniferous era, with everything that implies about what might be crawling through it. Hold on to the name Arrhenius. He is going to come back later in this story, and when he does, the return will be one of the strangest ironies in the history of science. Once the swamp had been proposed by a Nobel laureate, the culture ran with it, and it ran hard. For 50 years, Venus in fiction was a jungle world of dinosaurs, oceans, fern forests, and rain that never stopped falling. It appeared in pulp magazines and serious novels and children's encyclopedias, and to be clear about the state of knowledge at the time, none of it could be disproven, because nobody could see the ground. The jungle was defended in scientific journals for years. It was the reasonable position. There were dissenters, and their guesses are worth mentioning, because they show how wide open the question really was. Some argued the clouds were not water but dust, and the surface a global desert. One serious proposal held that the whole planet was covered in a worldwide ocean of carbonated water, a soda ocean, on the grounds that the atmosphere seemed rich in carbon dioxide. There were arguments for a world of oil. Every one of those pictures was published by competent people. And they cannot all be right, and in fact none of them were. Look at what that tells you. In the middle of the 20th century, humanity's best minds could not agree whether the nearest planet to us was a jungle, a desert, an ocean of soda water, or a sea of petroleum. That is not a small disagreement about a detail. That is a total absence of information about the planet next door. And here is the sentence I want to plant now, because the whole rest of this story grows out of it. Everything anyone believed about the surface of Venus before 1962 was not an observation. It was an inference, or a model, or a hope wearing the costume of a fact. That is the first uncomfortable truth of this journey. And it's worth being precise about how far it extends, because it extends further than most people realize. Even today, even now, no human eye has ever seen the surface of Venus. And let me be exact here, because I don't want to overstate it. We have photographs of the ground. There are a small number of real color images taken from the surface itself, and we'll stand in them later. And they are among the most extraordinary pictures our species has ever taken. But no telescope on Earth, and no orbiting camera, has ever simply looked down and seen the landscape of Venus the way you can look at the moon through binoculars, or the way any decent telescope can show you the ice caps of Mars. The cloud is total and permanent, with no gaps and no clear season. In visible light, from outside, the planet is opaque, and it has been opaque for the entire history of human observation and for a great deal longer than that. Everything we know about the surface of Venus, we know by other means. We know it because we bounced radar off it and read the echoes. We know it because we dropped machines through the clouds and listened to them for as long as they survived, which was never long. Our knowledge of the ground of that planet is assembled almost entirely from the last transmissions of dying spacecraft. That is a genuinely different relationship than we have with any other world in the solar system. We watch Mars in daylight. We have driven across it for years at a time. But the surface of Venus is something we have visited only in brief, violent, doomed increments, and every single time the planet killed the visitor. So before we go any further, let's be honest about how we know any of this, because the gaps turn out to be every bit as interesting as the data. There are things about Venus we've measured directly, standing on it with instruments. The temperature at the surface, the pressure, the composition of the air, the color of the light, the sound of the wind. These are not models. Machines sat on that ground and reported these numbers home before they died. And the numbers agree with each other across multiple missions and decades. When I tell you the surface temperature later, I am not telling you a prediction. I am telling you a reading. There are things we have mapped from orbit with radar, which sees straight through cloud as though it were not there. The shape of the whole planet, its mountains, its plains, its volcanoes, its craters. This is solid, and it is detailed, and it is why we can talk about the geography of a world nobody has ever looked at. Then there are the things we infer, and I will flag them each time we reach one. Whether Venus once had an ocean, what its early history looked like, why it spins the way it does, whether its volcanoes are erupting now. And then finally, there are the things we simply do not know, and there are more of them than the confident documentaries suggest. We do not know what makes the dark shapes in its clouds. We do not know for certain whether lightning flashes there. We do not know whether the ground is geologically alive or nearly still. We don't know whether anything is metabolizing in the acid layer 50 kilometers up. And the honest answer to that last one is almost certainly not. But not certainly not. Every one of those unknowns sits on the nearest planet to Earth. A world we can see from our own gardens with no equipment at all. So with that map of our own ignorance in hand, let's go and find the number that ended the jungle. The jungle did not die from a photograph. It died from a temperature reading taken by radio, and the reading was so far outside expectation that the people who took it spent years being told they had made a mistake. In the 1950s, radio astronomy was young, and one of the things a radio telescope can do is measure the natural microwave emission of a distant object, which is a way of taking its temperature without going anywhere near it. Astronomers pointed the new instruments at Venus and got a number that did not fit. It was not tropical. It was not even desert hot. The microwave signal implied a surface somewhere in the region of 300 degrees Celsius or higher, and later measurements pushed it higher still. That result was resisted, and the resistance was reasonable. Perhaps the emission came from high in the atmosphere rather than from the ground. Perhaps some exotic layer of charged particles was glowing. Perhaps the instruments were wrong. Whole papers were written to explain the heat away, and among the people who took the readings seriously and asked what could physically produce them was a graduate student named Sagan, decades before anyone outside astronomy knew his name. Sagan worked through the physics for his doctoral research and arrived at a conclusion most of his seniors disliked. The heat was real, he argued. It came from the ground, and it had a mechanism. That thick atmosphere of carbon dioxide would let sunlight in, and then refuse to let the resulting heat back out, trapping it, building it, running away with it, until the surface reached a temperature that had nothing to do with how close the planet sits to the Sunday. He was right. And a young man's homework, defended against senior opinion, is the reason the swamp died. But an argument on paper isn't a measurement, so let's go and take one, because the mission that settled it's the beginning of everything else in this story. It is 1962. The United States has never successfully flown a spacecraft to another planet, and neither has anyone else. Every attempt so far has failed. The first vehicle of the pair, Mariner 1, lifts off and immediately begins to wander off course. The guidance equations contain a single typographical error, one missing symbol in a line of code, and the rocket veers toward a populated area badly enough that a range safety officer has to push the destruct button less than 5 minutes into the flight. It was later called the most expensive punctuation error in history, and the description is not really an exaggeration. 5 weeks later, its twin, Mariner 2, rises from the same pad, and this time the rocket holds. What follows is a 3.5-month fall toward the sun by a machine that is slowly cooking. Mariner 2 was built for a journey nobody had made, and the engineering assumptions turn out to be optimistic. A solar panel fails. Temperature sensors climb past their design limits and keep climbing. Systems drop out one after another. And the engineers watching from Earth expect, more than once, to lose the spacecraft entirely. And somehow, it keeps flying. In December of 1962, Mariner 2 passes about 35,000 kilometers from Venus. And for a few minutes, its instruments sweep across the planet. It is the first successful visit to another world in the history of life on Earth. And the data it sends back does two things at once. It confirms that the heat is coming from the surface and not from some trick of the upper atmosphere. And it kills, permanently, every jungle, every ocean, every swamp, every dinosaur, and every soda sea that 3 centuries of human imagination had painted onto that blank white screen. There was no cloud forest down there at all. There was a furnace. Now, that's the moment the fantasy ended, but it's not the moment we learned what the surface was actually like, because a flyby can't tell you what it feels like to stand somewhere. For that, somebody had to land, and the story of who tried and what happened to them is one of the most extraordinary and least celebrated campaigns in the history of exploration. So let's take it slowly, because this is where our knowledge of that ground actually comes from, and because the pattern of these missions tells you more about Venus than any single number ever could. The Soviet Union decided to land on Venus and then simply refused to stop. The early attempts are a catalogue of failure. Probes lost to launch failures. Probes lost to dead radios in transit. In 1966, a capsule called Venera 3 struck the atmosphere of Venus and became the first human object ever to reach the surface of another planet. And it was silent long before it arrived. It delivered nothing but itself. Then, in 1967, Venera 4 did something better. It was built to descend on a parachute and report as it went. And it did exactly that, transmitting steadily as it sank into the clouds, sending back the first direct measurements of the air of another world. And then it stopped. The signal ended while the probe was still, by later reckoning, roughly 25 kilometers above the ground. Understand what that means, because this is the moment Venus first showed its teeth. The engineers had built a vessel to survive the conditions they expected at the surface. The vessel was crushed like a can before it got close. Whatever was down there was so far beyond the estimate that a spacecraft designed for it failed at an altitude where it should have still had a long way to fall. Most programs would have paused there. This one didn't. And here is the detail I find genuinely remarkable about the Venera campaign, because it is the opposite of how failure usually gets interpreted. The Soviet engineers did not conclude that Venus was impossible. They concluded that they had built too gently, so they built harder. Venera 5 and Venera 6, reinforced, went deeper into that atmosphere and were crushed lower down. Each death delivered data, and each set of data fed the next design. And the vessels grew heavier and stronger, and more like something you'd send to the bottom of an ocean than something you'd send into space. In 1970, Venera 7 arrived. It was built like a bathyscaphe. It went down through the clouds under a parachute that was itself failing in the heat, and something went wrong in the final phase, and the probe struck the surface hard and tipped over onto its side. Its antenna, now pointed at the ground instead of at Earth, radiated a signal so weak that mission controllers initially thought they had lost it, and only afterward When engineers went back and cleaned up the recording, did they find it? 23 minutes of faint data transmitted from the surface of Venus by a machine lying on its side. It was the first time any human object had ever landed on another planet and reported home. And what it reported was the number that Sagan's homework had implied. The temperature at the ground was somewhere around 475 degrees Celsius. And before we go on, let's do something with that number, because a figure that large stops meaning anything if you only hear it. The mean surface temperature of Venus is roughly 465 degrees Celsius. In Fahrenheit, that is roughly 870 degrees. Take a moment with each of the following, because this figure is going to follow us all the way to the end of this story. That temperature is hotter than the surface of Mercury. And Mercury orbits nearly twice as close to the Sunday sit, with that a moment. Because it is the first, genuinely counterintuitive thing this planet does. The furnace is not the world standing nearest the fire. It is hotter than the melting point of lead, so a lead weight placed on the ground of Venus would slump and spread into a puddle. It's hotter than the melting point of tin, and of zinc, and of the solder holding together the electronics in whatever device you might be listening to this on. It's as hot as the inside of a self-cleaning oven at the fiercest moment of its cycle, which is the single hottest condition an ordinary home is capable of producing, sustained without pause across the entire surface of a planet. And here is the part that people consistently underestimate, so I want to state it separately. That temperature is not a daytime maximum. It is not an equatorial extreme. It is not a record measured in some particularly unlucky basin. On Earth, heat is an event. It has a location and an hour. A desert scorches at noon and grows cold enough to be dangerous by midnight. The hottest temperature ever recorded on our planet and the coldest temperature ever recorded on our planet are separated by nearly 150 degrees Celsius, and the difference between a summer afternoon in one place and a winter night in another is the ordinary background of human life. Venus does not do that. From the equator to the poles, from the middle of its long day to the middle of its long night, from one end of its year to the other, the surface temperature barely moves. A handful of degrees, planet-wide. There is no season, there is no shade, there is no cool hour before dawn, no north to travel to, no altitude worth climbing for, nothing that behaves like weather in the sense you mean the word. The heat on Venus is not a condition of the place, it is the definition of the place. So Venera 7 gave us the temperature, and the program kept going, and now the machines start doing something more than dying usefully. They start looking around. In 1975, Venera 9 descended onto the plains of a region called Phoebe Reggio, and it did not merely land, it survived on the surface for 53 minutes. And during that time it opened an eye. That is the moment I would put at the center of this whole story if I had to choose one. The first photograph ever taken from the surface of another planet. Not an artist's impression, and not a radar map. A picture taken by a camera on the ground on Venus. And what did it show? Rocks. Flat, angular, broken rocks, spread out to a horizon that was slightly closer than it should have been, under a light nobody had predicted. The scientists expected the surface to be nearly dark, on the reasonable assumption that 50 kilometers of thick cloud would strangle the sunlight before it arrived. They were wrong. It was bright enough down there to photograph without a lamp. Roughly the light of an overcast day. Later missions brought color, and the color is what makes those images unforgettable. Venera 13 and 14 returned panoramas showing flat plates of amber-tinted rock under a sky, the color of a smoky orange lamp. Everything is that same tone. The ground, the air, the light. The thick atmosphere scatters away the blues, and what is left is a world made entirely of ember colors, like the inside of a lit room with all of the daylight boiled out of it. Venera 13 also carried microphones, and in doing so it recorded the sounds of Venus, the first sounds ever captured on the surface of another planet. What came back was a low, slow wind, and the noises of the machine itself as it worked. The wind on Venus barely moves, but the air is so dense that even a slow current has the pressing weight of deep water. It is the sound of a very heavy, very lazy ocean of gas. And these machines were not merely operating in a hostile place. They were dying while they worked, on a clock. And they knew it, in the sense that their designers knew it. Here is the detail from all those doomed missions that matters most for this story, and it is not the one people expect. Every Venera lander died the same death, and it was not crushing. It was heat, and the pressure vessels themselves held perfectly well. What killed them was temperature, creeping inward through every seam and window, warming the interior degree by degree until the electronics inside stopped being electronics. The Soviet engineers filled them with heat sinks, pre-chilled them before entry, packed them with lithium salts that absorbed warmth by melting, and every one of those tricks bought minutes. The longest any spacecraft has ever survived on the surface of Venus is 127 minutes. That record belongs to Venera 13, and it has stood since 1982, 2 hours and 7 minutes. That is the entire operational lifetime of the best machine we've ever placed on that ground. And it's worth remembering when we get to the part of this story where people talk about living there. And because this program deserves to be remembered as more than a list of casualties, there are 2 stories from it that I want to tell you properly, both of which are true and one of which is quietly hilarious. The camera windows on a Venera lander were sealed for the descent under a protective cover, designed to spring off once the machine was safely down. On Venera 11, the covers refused to release. The lander worked, and the cameras worked, and the machine stood on the surface of Venus for 95 minutes with its eyes closed, transmitting nothing but darkness. On Venera 12, the same thing happened again. 2 successful landings on the deadliest surface in the solar system, 4 sealed eyes, and not one photograph between them. The engineers redesigned everything, and on Venera 13 and 14 the covers finally sprang away exactly as intended. Which brings us to the moment that space engineers still wince at. Venera 14 carried an arm designed to swing down and press a small instrument against the ground to measure the compressibility of the soil. The arm swung down perfectly, and it pressed, and it measured, and what it measured was the discarded lens cap from its own camera, which had popped off and landed, out of all the available square kilometers of Venus, precisely under the one spot the arm was going to touch. The instrument dutifully reported the mechanical properties of a piece of Soviet spacecraft. On the first and only opportunity it would ever have. I tell you that story partly because it's funny and partly because it's a reminder of how thin our knowledge of that ground actually is. We are not talking about decades of patient fieldwork. We are talking about a handful of machines that survived for minutes at a time 4 decades ago, in a small number of locations, whose collected working lifetimes on the surface of Venus add up to less than 1 working day. That is the evidence. It is real, it is direct, and it is astonishingly small. Before we go down and stand there ourselves, there's one more chapter in how we came to know this planet, and it's my favorite thing that Venus has ever done for us. Because for one strange period in history, humanity used this world, the one that shows us nothing, to measure everything. Here is the problem that the 1700s faced. Astronomers of that era understood the shape of the solar system perfectly, and its size not at all. The laws of planetary motion gave them every proportion exactly. They knew Venus orbits at roughly 72 hundredths of Earth's distance from the Sunday. They knew Jupiter sits about 5 times further out than we do. Every ratio, precise. But a map of ratios has no scale bar. Nobody could say whether the sun hung 8 million miles away, or 80 million, or 800 million. Humanity possessed a perfect map of its own neighborhood, and could not state the size of the neighborhood. One measurement would unlock all of it, the true distance from the Earth to the sun, and from that single number, the real dimensions of everything, and Edmund Halley, the man the comet is named for, worked out that Venus could provide it. The method depends on the rarest thing this planet does. Occasionally, roughly twice a century, the geometry lines up exactly, and Venus passes directly between us and the Sun, appearing as a small black dot, crawling slowly across that enormous bright face. If observers stationed at widely separated points on the Earth each timed that crossing precisely, the dot would appear to take a slightly different path from each station, shifted the way your thumb shifts against a far wall when you close one eye and then the other. From those tiny disagreements, geometry could extract the distance to the Sunday. Halley published the method in detail. And then he looked at the calendar. The next transits would fall in 1761 and 1769. Halley was already an old man. He knew with total certainty that he would be decades dead before either of them arrived. So he wrote instructions to astronomers who had not yet been born. He set out what they should do, where they should go, what to measure, how to record it, and he urged them across the years to sail to the ends of the earth when the day came and to finish what he could not attend. I find that one of the quietest brave things anyone in science has ever done. He aimed an experiment across time, at strangers, and trusted them to run it, and they went, all of them. When the transit of 1761 approached, the scientific academies of Europe organized something that had never existed before, a coordinated global observation, and it's reasonably called the first worldwide scientific experiment in human history. Roughly 120 observers scattered across the planet, to Siberia, to South Africa, to India, to Newfoundland, to the island of St. Helena. And they did it during a world war. Britain and France were tearing at one another across every ocean on Earth, and yet astronomers from each nation were issued letters of safe passage by the enemy, with warships instructed not to fire on vessels whose only cargo was telescopes and clocks. Whatever else you believe about that century, hold on to that image. Two empires at war agreed, in writing, that this measurement mattered more than the war did. On the day itself, the sky produced a complication nobody had anticipated. As the planet slid onto the face of the Sun, observers watching through their eyepieces saw the black disk of Venus stretch and cling to the solar edge, like a drop of ink refusing to separate, smearing the precise instant of contact that the entire method depended on. It is called the black drop effect, and it degraded the timings everywhere. But in St. Petersburg, a Russian scientist named Mikhail Lomonosov noticed something better than what he had come for. As Venus crossed onto the Sun, he saw a thin luminous ring flare briefly around the planet's dark edge. Sunlight bending through something that surrounded it. He is credited with drawing the correct conclusion immediately. Venus has an atmosphere. Think about the shape of that. The first genuine physical fact humanity ever learned about Venus itself, discovered by accident during an attempt to use the planet as nothing more than a surveyor's marker, was the existence of the very atmosphere this whole story is about. The veil announced itself in a ring of light. The second transit, in 1769, produced the most famous voyage in the history of exploration, and the saddest one, and they belong together. The famous voyage went to a young naval lieutenant named James Cook, sent by Britain in a converted coal ship called the Endeavour to carry astronomers halfway around the world to the newly charted island of Tahiti, for the sole purpose of timing that black dot from the southern seas. They made the observation from a sandy point on the northern shore, which is called Point Venus to this day. And when the transit was over, Cook opened a set of sealed orders and sailed on, charting New Zealand and the eastern coast of Australia on the way home. Follow that chain, because it is worth following. A significant part of the European mapping of the far side of the Earth happened as a side effect of an errand to Venus. The saddest voyage belonged to a French astronomer named Guillaume Le Gentil. And if any story in the history of astronomy deserves to be told slowly, it's his. He left Paris in 1760, bound for the French colony of Pondicherry in India to observe the first transit. War arrived at the colony before he did. With Pondicherry besieged and then captured by the British, his ship was still tacking around the Indian Ocean on the morning of the transit, and he watched the appointed hours pass from a rolling deck where no precise measurement was possible. The sky, that morning, was perfectly clear. Most people would have gone home. Le Gentil looked at the calendar, saw that the second transit would arrive in 8 years, and decided to stay in the Indian Ocean and wait for it. 8 years. He filled them with expeditions and surveys and genuine scientific work. As the day drew closer, he agonized over where the June weather would be kindest, considered Manila, and finally settled on Pondicherry, now returned to French control, where he built himself a small observatory and waited underneath weeks of flawless blue sky. On the morning of the 3rd of June, 1769, a single patch of cloud drifted across the Sunday. It arrived shortly before the transit began. It dissolved shortly after the transit ended. And behind it, entirely invisible to the man who had crossed the world and given a third of his adult life to this moment, Venus made its crossing. In Manila, the sky that morning was clear. He nearly lost his reason. And when he finally reached France, after 11.5 years away, he discovered that he had been declared dead. His heirs were dividing his estate. His seat at the Academy of Sciences had been given to another man. It took the intervention of the king to restore his affairs. And here, at least, the story softens, because it does not end in bitterness. He married. He had a daughter he adored. He lived another 20 years, and by every account he was a contented man who had made his peace with the most patient bad luck in the history of astronomy. Spare him a kind thought. He gave 11 years to a dot he never saw. Now, was any of it worth it? That is a fair question to ask of an enterprise that cost that much. And it worked. When the timings from Tahiti and Siberia and Hudson Bay and India were finally gathered and combined, black drop and all, the astronomers computed the distance from the Earth to the Sun and landed within roughly 2% of the value we accept today, about 93 million miles. The scale bar was drawn, and with it came the true size of the solar system, the real distance to every planet, the actual dimensions of everything any telescope had ever shown anyone. So sit with that irony for a moment, because it is the deepest one this planet has to offer. Venus, the world that hides its own face more completely than any other object in the sky, is the world that told humanity how large the universe's furniture actually is. The planet that shows us nothing gave us the size of everything. And it kept the same secret through all of it. Cook sailed to Tahiti and back. Le Gentil gave 11 years, 120 observers crossed a world at war, and not one of them, at any moment, saw the surface of the planet they were measuring. That took 2 more centuries. And it took radar. In 1990, an American orbiter called Magellan arrived at Venus, carrying an instrument that could do what no eye and no camera ever could. Radar does not care about cloud. It passes through as though the atmosphere were not there, strikes the ground, and returns. And from the timing and strength of those echoes, you can reconstruct a landscape. For 4 years, Magellan swept the planet strip by strip and built the map that 3.5 centuries of telescopes had failed to produce. 98% of the surface. Mountains, plains, craters, volcanoes, ridges, all of it resolved for the first time. The blank screen finally became a place. It acquired geography, and with geography came names. The naming is worth a moment, because it is quietly lovely. The highest range on the planet was called Maxwell, after the physicist, and the 2 great highland continents were named Ishtar and Aphrodite, after the goddesses. And then, by international agreement, essentially everything else on Venus, every crater, every plain, every ridge and valley, was named for women, real and mythological, drawn from every culture on Earth. Venus is the only world in the solar system mapped almost entirely with women's names. A planet of craters called after poets and scientists and queens and goddesses, on a surface that would destroy any of them in an hour. And that map is what we are about to walk into. Because now we know the shape of the ground. So now, let's go and stand on it. Here is the scenario, and I want to state it plainly so that we both know what we are doing. For the next stretch of this journey, we are going to assume something impossible. We are going to assume that you can stand on the surface of Venus and remain conscious and observing, protected from the immediate consequences, for as long as it takes to look around properly. Nothing that follows is a survival plan. Everything that follows is a description of what is actually there, taken from real measurements, and the only fiction is you. Because the honest version, which we'll come back to, is that a human being placed on that surface without protection would be dead long before the brain had finished processing the view. So, you are standing on the plains of Venus. We'll take it one sense at a time in the order your body would report them. The first thing is not the heat. I want to correct that expectation early, because everybody assumes the heat announces itself first, and it does not. The first thing is the weight. The atmospheric pressure at the surface of Venus is roughly 92 times the pressure you are sitting in right now. 92 atmospheres. And that number, spoken aloud, sounds like a technical specification rather than an experience. So let us do the only thing that makes it real. So let's turn it into water, because water is a pressure everybody has felt. You know what it feels like to dive to the bottom of a swimming pool. 3 meters, maybe 4, and already your ears complain and you have to swallow to equalize them. That is a third of an atmosphere of extra pressure. Your body notices immediately. 10 meters of seawater is 1 extra atmosphere. That is the standard exchange rate. And it's the only piece of arithmetic in this whole story that you need to remember. Because from here, everything follows. So walk it down with me, and take it slowly, because the point of this exercise is the walking rather than the arrival. 10 meters, and the pressure has doubled from the surface value. Any competent swimmer can reach this. 40 meters, and you're at the outer limit of recreational scuba diving, 5 atmospheres, in a world of blue-green dimness where colors have started to disappear. 100 meters. Now we are past what almost any human being can do. The record holders in free diving reach this depth and beyond on a single held breath, and their lungs compress to a fraction of their surface volume, and their bodies shunt blood inward to keep the chest from collapsing. 11 atmospheres. Human beings have been here, and it is close to the edge of what a body can be trained to survive. 200 meters, and we have left human beings behind entirely. 21 atmospheres. This is submarine territory now. Most military submarines ever built are already at or beyond their operating limits somewhere around here. 330 meters. This is roughly the depth of the deepest dive ever made by a nuclear submarine. 34 atmospheres. The hull of a warship, built of high-strength steel, is groaning. We are still nowhere near Venus. 500 meters and 51 atmospheres. There are almost no crewed vehicles in the world that operate here. 700 meters and 71 atmospheres. We are into the realm where you send robots and nothing else. 900 meters. 91 atmospheres. Stop there. That is the surface of Venus. Standing on the ground of Venus is mechanically equivalent to standing at the bottom of 900 meters of ocean, not floating in it. Standing on the floor of it, with the entire weight of that column pressing on every square centimeter of you, from every direction, permanently. And there is no submarine on Earth that can take a crew to 900 meters and bring them back. That depth belongs to specialized deep-diving research vessels and unmanned machines. The pressure at the surface of Venus is a pressure that our species, on our own planet, mostly sends robots to handle. Now hold the two facts together, because separately they are impressive, and together they are something else. That crushing weight and the 870 degrees in the same place at the same time, everywhere on the planet, with no location and no season and no hour of the night that offers relief from either. This is why the Venera landers looked like bathyspheres. They were not spacecraft in the ordinary sense. They were deep-sea vessels that happened to be launched into space, and they were being asked to survive an oven at the same time. And now, a detail that I think is the single strangest physical fact about this world, and one that almost never gets mentioned. At those pressures and those temperatures, the carbon dioxide filling the lower atmosphere of Venus stops behaving like a gas. It becomes what physicists call a supercritical fluid, which is a state of matter with no everyday equivalent and no obvious way to picture, because we've nothing like it in ordinary life. It is not a liquid, it is not a gas. It flows and fills its container like a gas, but it carries the density and the dissolving power of a liquid, and there's no surface anywhere in it, no boundary, no shimmer, nothing you could point at and call the top of it. So the thing you would be standing in on Venus is not really air, and it is not really an ocean. It is something in between that our language was never built to name. The density at the surface is about 65 times the density of the air in the room around you, which is roughly a 20th the density of liquid water, which means moving through it would be nothing like walking. It would be like wading. Every step displaces a fluid that pushes back. Every arm movement has to shove something aside. And you'd feel a faint but genuine buoyancy, the way you do standing chest deep in a swimming pool, because you'd be, in a small but real way, floating in the air of Venus. That is what the atmosphere does to you mechanically. Now, let's look at what it does to the view, because this is where the world turns beautiful, and it picks the worst imaginable moment to do it. Look around you, and the horizon isn't right. It is closer than it should be, and it is curved upward. And the reason is that the immense density of that atmosphere bends light. Refraction on Venus is powerful enough that your line of sight curves gently with the surface, lifting the distant ground into view. Stand on that plane, and the landscape appears to rise slightly toward the edges in every direction, so that you feel, subtly and permanently, as though you're standing in the bottom of a vast shallow bowl. You could never walk out of it. Either. The bowl would travel with you, always centered exactly where you stand. On Venus, you are always at the lowest point of the world. Now look at the light itself. It is not dark, which is the first surprise. The clouds are 50 kilometers thick, and they scatter and absorb most of what arrives. But enough gets through that the surface sits in a light roughly comparable to a heavily overcast day on Earth, or the light in a room with the lamps off and the curtains drawn on a grey afternoon. You could read by it. The Venera cameras photographed by it without needing lamps, but every trace of blue has been stripped out. The thick air scatters short wavelengths away long before they reach the ground, and what survives the descent is the long end of the spectrum, the oranges and the ambers and the deep dull reds. So everything, and I mean everything, is that colour. The rocks are amber, the dust is amber, the distant hills are amber. The sky, if you look up, has no blue in it anywhere, and no sun in it either. Only a diffuse, dull glow like the inside of an enormous paper lantern. There are no shadows with edges, because there is no point source of light left to cast one. The illumination arrives from the entire dome of the sky at once, soft and shadowless and completely even. It's the light of a furnace room seen through smoked glass, and it never changes. And it's the same at what would be noon and what would be midnight, if either of those words applied here. Now listen for a moment. There is sound on Venus, and this is one of the few places where we don't have to speculate, because Venera 13 carried microphones and recorded it. The wind at the surface moves slowly, about a meter per second, roughly the pace of a gentle stroll. On Earth, That is a breeze so mild you would barely register it on your face. Here it is not mild at all. Because the air is 65 times denser, that lazy little current carries a real shove, and the correct comparison isn't wind but a slow water current pressing against your legs in a river. It would push you, steadily, patiently, with the weight of something much heavier than air, and the sound of it is deep. In that dense atmosphere, sound travels faster and carries differently, and low frequencies dominate. Your own voice, if you could speak, would come out strange and pitched oddly, in the way that breathing an unusual gas mixture distorts a voice, only more so. So the sensory summary of standing on the surface of Venus goes like this: a shallow amber bowl of a world, lit like a permanently overcast afternoon with all the colour drained out except the ember end. Flat broken plates of rock to a horizon that curls up at the edges. A hot, slow river of invisible fluid pressing against you. A low, continuous sound of something enormous, moving very slowly. No shadows, no sun, and no change in any direction. Ever. And now let us stop pretending and answer the question the whole scenario has been holding back. What would this actually do to a human body? The end would not come from the heat, and it would not come from being crushed. And this is the detail that surprises most people. Crushing requires a pressure difference, and the pressure would equalize through you almost instantly. You would not be flattened. You would simply be filled. The heat would kill you, certainly, but heat takes time to move through flesh, and that is the point. Something else would get there first. The atmosphere of Venus is more than 96% carbon dioxide, and at 92 atmospheres of pressure, the amount of it forced into your bloodstream with each breath would be lethal within a small number of breaths. You would lose consciousness quickly from carbon dioxide toxicity, well before the temperature had finished doing its work. So the honest answer, told plainly, is this. A human being standing unprotected on the surface of Venus would be simultaneously cooking, drowning in carbon dioxide, and being chemically burned, and would be dead in well under a minute, and the immediate cause would be the air itself. That is what makes Venus different from every other hostile place we talk about. On Mars, you need a suit and a supply of air. On the Moon, the same. In both cases, the world is an absence, and you bring what is missing. Venus is not an absence. Venus is a presence. It has plenty of atmosphere, and plenty of warmth, and plenty of chemistry, and every one of those things is actively trying to take you apart. The Moon will let you alone if you bring your own everything. Venus will not let you alone under any circumstances. And remember what our best machines managed against that. 127 minutes. That is the ground floor. So now, let's look up. Because the sky of Venus is even stranger than its ground. Every world you've ever heard described has a day and a year, and the relationship between them is so consistent across the solar system that nobody thinks to state it. The day is the short one. The year is the long one. A planet spins many times while it goes around once. Venus doesn't do this at all. A single rotation of Venus, one turn on its axis measured against the stars, takes about 243 Earth days. One orbit of Venus around the Sun takes about 225 Earth days. Read those two numbers again, in that order. The day is longer than the year. On Venus, the planet finishes its trip around the Sun before it finishes turning around once. The calendar overtakes the clock. And there is no other planet in the solar system where this is true. And it gets stranger, because it also turns the wrong way. Every major planet in the solar system spins in the same direction it orbits, counterclockwise seen from above the north of the Sun, because they all condensed out of the same rotating disk of material and inherited the same handedness. It is one of the great fingerprints of how solar systems form. Venus spins backwards, slowly, ponderously, in the opposite direction to nearly everything else, which means that if you could see the Sun from the surface of Venus, and we'll get to why you can't, it would rise in the west and set in the east. Now, the rotation is so slow and the orbital motion so relatively quick that the sensible way to describe the day, there's not the spin at all, but the solar day, the time from one noon to the next, and that works out to about 117 Earth days. So let's put together the timetable of an ordinary day on Venus. Roughly 58 Earth days of continuous daylight. Then, roughly 58 Earth days of continuous darkness. Then, the sun comes up again, backwards, in the west. 2 months of light, then 2 months of dark, then 2 months of light again. Sit with what that would do to any body, including yours. Every biological rhythm you have, every sleeping and waking cycle, every hormonal tide, is tuned to a planet that turns once every 24 hours. Put a human being on a world where the light lasts 8 weeks and then the dark lasts 8 weeks, and you've removed the metronome that all terrestrial life has kept time to since life began. And now, let me take the whole thing away, because here is where the sky of Venus stops being merely strange and becomes something genuinely unique in the solar system. None of that would be visible. You would never see the sun rise in the west, because you would never see the Sunday. The cloud deck is permanent, unbroken, and global. It has no seasons, no gaps, no clear days. In all the history of Venus, nothing standing on its surface has ever seen the disk of the Sunday. There is light, that diffuse amber glow, and it slowly brightens and slowly dims across those 2-month cycles. But there's no source in the sky to point at, and it goes further. No one on the surface of Venus has ever seen a star. Not one, ever, in the entire lifetime of the planet. No constellations, no Milky Way, no moon, no planets, not even the bright blue one hanging nearby that would be the loveliest thing in that sky, if anything down there could see it. Think about what that means for the history of a world. Every scientific revolution our species has ever had began with somebody looking up. Astronomy comes first, before chemistry, before physics, because the sky is the one laboratory that is free and open to everyone. Navigation, calendars, the seasons, the very idea that we live on a body moving through a larger space, all of it came from watching points of light move. A civilization on the surface of Venus, if such an absurd thing could exist, would have no astronomy at all. It would have no way to know that anything existed beyond the lid. It would have no stars to name, no seasons to track, no way to suspect the universe was there. We think of the night sky as the default condition of a planet. It is not. It is a privilege of thin, clear air, and Venus does not have it. And there is one more absence up there, above the cloud, that would matter to anyone who ever floated in that sky. Venus has no moon at all, along with Mercury. It is one of only 2 planets in the solar system that travels entirely alone. Every other planet out there carries a retinue, from our single large companion to the dozens upon dozens circling the giants. Venus has nothing. No companion has ever risen over that horizon in the whole history of the world, and nobody fully knows why. Perhaps it never captured one. Perhaps it formed one, and the sun's gravity, so close at this distance, eventually stripped it away. Perhaps, in some versions of the great collision story that reversed the planet's spin, it had a moon once, and the same event that turned the world over sent its companion spiraling in to be destroyed. We do not know. What we know is that of all the planets, the one we call our twin is the loneliest object of its kind in the inner solar system. Now, about that backwards rotation. Why does the planet turn the wrong way, and so slowly? This is one of those places where I have to be honest and tell you the answer is not settled. There are 2 leading explanations, and both of them are strange. The first is the collision story. Early in its history, Venus was struck by something enormous, a body large enough to stop and reverse the spin of a planet. The solar system was violent in its youth, and impacts of that scale genuinely happened. Our own moon is the debris of one. The second is the atmosphere story, and I find it more unsettling because it requires no single dramatic event. In this version, the planet was never hit at all. The sun's gravity raises tides in that colossal atmosphere, and the atmosphere drags on the planet. And over billions of years, patiently, without any single moment of catastrophe, that friction slowed the spin, stopped it, and turned it over. In that second story, the atmosphere of Venus did not merely blanket the planet. It took the planet's rotation away from it. The air stopped the world, and here is the detail that makes the whole question more interesting rather than less. The rotation of Venus is not even constant. When different spacecraft, years apart, measured the length of that rotation with high precision, they got answers that disagreed by minutes. Not measurement error. The planet's spin genuinely appears to change slightly over time. And the best explanation is that the massive atmosphere is exchanging momentum with the solid body underneath, speeding it and slowing it as it goes. The clock is not just broken. The clock is being interfered with by the air. Now let's look at the clouds themselves, because we've been standing underneath them for a while now without asking what they're actually made of. They are not water. On a world this hot, water in any liquid form is impossible at the surface. The clouds of Venus are droplets of sulfuric acid, concentrated to something in the region of 75 to 96%, which is stronger than the acid in a car battery. And it rains. High in that deck, droplets grow heavy enough to fall, and they fall as genuine rain. A rain of concentrated acid drifting down through an amber sky. It has never reached the ground. The rain of Venus falls from roughly 50 kilometers up, and somewhere around 30 kilometers, the temperature climbing steadily as it descends. Every droplet boils away back into vapor. The vapor rises, cools, condenses, and falls again. This is a real weather system with real precipitation running continuously on a planet where precipitation has never once landed. On Earth, we have a name for rain that evaporates before it arrives. It's called virga. And it's a curiosity, an occasional feature of dry desert skies, a grey fringe hanging under a cloud that never quite makes it down. On Venus, virga is the entire hydrological cycle. The planet has been raining for hundreds of millions of years and its ground has stayed dry the entire time. And now the mountaintops, which is my favourite thing on the whole surface. When Magellan's radar mapped the highlands, it found something on the peaks that made no sense at first. The mountaintops are bright, radar bright, meaning they reflect strongly, in a way that is characteristic of metal rather than rock, and the effect switches on above a particular altitude, the way a snow line switches on above a particular altitude in a mountain range on Earth. The mountains of Venus are frosted. They are capped with something bright and reflective, and it starts at a consistent height. And it looks, in the data, exactly the way an alpine snow line looks from the air. It can't possibly be snow, not at these temperatures. And the leading explanation is far stranger than snow. Down on the lowlands, where the air is hottest, certain heavy metallic compounds slowly vaporize into the atmosphere and drift as a thin metallic haze. When that haze reaches the high peaks, where the air is a precious few dozen degrees cooler, it condenses out. It snows metal on the mountains of Venus. Frost made of something like lead and bismuth compounds, settling out of the sky onto the highest ground, in a slow, permanent metallic winter that has never once been cold. That is the world under the veil. So now, let's look at the veil itself, because it keeps secrets of its own, and some of them are still unsolved. The first mystery is a matter of speed, and it is one of the great unsolved problems in planetary science. The solid body of Venus turns once every 243 days. It is the slowest spinning large object in the solar system, a world that barely rotates at all. Its atmosphere goes around every 4 days. The cloud tops of Venus race around the planet roughly 60 times faster than the planet beneath them turns. The winds up there run at something like 360 kilometers per hour, continuously, all the way around the world, a permanent hurricane-speed river of air circling a planet that's essentially standing still. Astronomers call this super-rotation, and I want to be clear that naming it is not the same as explaining it. We do not fully know why it happens. Something is transferring momentum upward from the slow surface into the fast sky, and maintaining it there against friction, permanently. And while there are good candidate mechanisms involving thermal tides and waves in the atmosphere, the complete explanation isn't settled. The slowest turning planet in the solar system wears the fastest continuous winds, and we cannot entirely say why. There is a related feature at the poles that I want to show you, partly because it's extraordinary and partly because the story of the spacecraft that photographed it's one of the great second chances in exploration. Above each pole of Venus sits an enormous permanent storm, a vortex kilometers deep, and it does something no storm on Earth does. It has 2 centers. The circulation splits into a double eye that rotates around itself, tears apart, reforms, and is never the same on any 2 days, and never gone. A storm with 2 pupils staring out of the top of the planet. And the spacecraft that gave us the best modern look at that atmosphere very nearly never arrived. Japan's first Venus orbiter was named Akatsuki, which means dawn. In December of 2010, it reached the planet and began the engine burn that would break it into orbit. Partway through the burn, the engine died. A blocked valve had starved it. The nozzle tore itself apart, and the spacecraft, unable to slow down, sailed straight past Venus and fell into orbit around the Sun instead. For most missions, that is the end. A probe that misses its planet does not get another chance, because the 2 drift apart onto separate paths. But the engineers in Japan did the orbital arithmetic and found a thread of hope. If they could keep their wounded spacecraft alive, the geometry would bring it back around to meet Venus again in 5 years. So they waited. For 5 years, Akatsuki circled the Sun, closer in than it had ever been designed to fly, slowly baking, while its operators nursed its systems and rehearsed a maneuver nobody had attempted. The main engine was dead. All that remained were the small attitude thrusters, little jets built for nudging and pointing, never for planetary capture. In December of 2015, 5 years to the month after the failure, they turned the spacecraft, fired those small thrusters continuously for roughly 20 minutes, and waited across 100 million kilometers to find out whether it had worked. And it worked. Akatsuki slid into orbit around Venus, the first spacecraft in history to miss its planet, and then catch it on the rebound. And within weeks, the resurrected orbiter photographed something stranger still. Stretched across the entire face of the planet, from pole to pole, stood an enormous bow-shaped bright wave in the cloud tops, some 10,000 kilometers long. And it was not moving. The fastest sustained winds in the inner solar system were tearing past underneath it at 360 kilometers per hour. And this structure simply stood there, fixed in place, apparently anchored to a highland region on the ground far below, a standing wave in the sky, holding still above a mountain in a hurricane that never stops. The second mystery has been staring at us since the 1970s, and it is the most quietly unsettling fact in this whole account. If you photograph Venus in ultraviolet light, the blank white face disappears. Instead, you see structure, dark streaks and bands and swirls, curling through the cloud tops, changing from day to day, riding the super-rotating winds around the planet. Something up there is absorbing ultraviolet light. Something is soaking up roughly half the solar energy the planet takes in, which means this substance isn't a curiosity. It's a major component of how the entire climate works. And after more than 50 years of study, we do not know what it is. It has a name, and the name is an admission. It is called the unknown absorber. Candidates have been proposed for decades. Various sulfur compounds, iron chloride, something photochemical we have not pinned down. None of them fully match the observations, so let me state it as plainly as it deserves. On the nearest planet to Earth, more than 60 years into the space age, there are dark shapes drifting through the clouds. They are visible from here. They absorb half the sunlight the planet receives, and nobody can tell you what they are made of. The third mystery is one I find almost funny in its stubbornness, because it concerns something that should be the easiest thing in the world to confirm. Does it lightning on Venus? For 50 years, spacecraft have been picking up the radio signatures of what look like electrical discharges. The characteristic crackles and whistles that thunderstorms produce on Earth have been detected there repeatedly by multiple missions arriving in bursts. And in 50 years, no camera has ever caught a single clear flash. Orbiter after orbiter has looked. Optical searches have come up essentially empty. Some researchers argue the radio signals come from something else entirely, and there is no lightning at all. Others argue the flashes are there but rare, or buried in the wrong layer, or too faint against the glow. Consider the strangeness of that. We can detect lightning on Jupiter. We can measure the chemical composition of a planet's atmosphere circling another star. We can photograph the shadow of a black hole in a galaxy 50 million light-years away, and we cannot tell you whether it is thundering on the planet next door. The fourth mystery has been reported for 3.5 centuries and is only now being taken seriously. Astronomers watching the unlit night side of Venus through telescopes have claimed, over and over since the 1600s, to see a faint grey luminescence there, a glow on the dark part of the disk, where, by all rights, there should be nothing. It was named the Ashen Light, and for most of its history it was dismissed as an illusion, an artifact of tired eyes and imperfect optics. Modern instruments have found that the night side of Venus does genuinely glow. High in the atmosphere, oxygen atoms that were split apart by sunlight on the day side get carried around to the night side by those enormous winds, and when they recombine there, they release their energy as a faint airglow. Whether that particular mechanism accounts for what those old astronomers reported through their brass telescopes is still argued over. But the planet does shine faintly in the dark, and the people who insisted they saw something were not simply imagining it. And then there is the fifth one, which is the strangest idea attached to this planet, and much older than most people realize. In 1967, 2 scientists published a short paper in one of the world's leading journals proposing something that sounds like fiction and was argued like physics. The clouds of Venus, they pointed out, contain a layer where the temperature is mild, where water exists at least in traces, where sunlight is abundant. Such a place, they suggested, could not be ruled out as a habitat for simple airborne life. Microorganisms permanently suspended in the sky, perhaps buoyed by small gas bladders, feeding on sunlight, never touching the deadly ground. One author was the biophysicist Harold Morowitz. The other was Carl Sagan. Let that land properly. The same scientist whose calculations condemned the surface of Venus, the man who did as much as anyone to replace the jungle with the furnace, turned around a few years later and pointed at the sky above that furnace and argued that the old fantasy might simply have been filed at the wrong altitude. He closed the door on the ground and left a window open above it, and the reasoning was never idle. On Earth, life is found wherever water and energy occur together, including in boiling springs, in frozen brine, and in acid drainage more corrosive than anything on a laboratory shelf. The temperate cloud layer of Venus offers water, energy, and chemistry continuously. The gap in the argument was always the same. No sample, no measurement, no way to know. Then, in 2020, it appeared that the clouds had answered. a team of astronomers announced they had detected traces of a gas called phosphine high in that acid layer. On Earth, phosphine is produced almost entirely by living things and by industry. For a few extraordinary weeks, newspapers around the world carried a question nobody had expected to see in their lifetimes. Then came the reanalysis, which is the part of science that rarely makes headlines. Other teams reprocessed the data and could not confirm the signal. Some found the apparent detection could be explained by artifacts in the processing or by a different molecule with overlapping features. The original team stood by a weaker version of the result. Further observations have gone back and forth ever since. Where that stands today is genuinely unresolved. And the honest summary is this. There is a disputed whisper of a gas that should not be there, in a layer of a planet that's otherwise the most Earth-like environment beyond Earth. And we've not been back with the right instrument to settle it. So that is the veil. 100-kilometer deep envelope of acid and carbon dioxide, racing around the planet 60 times faster than the planet turns, streaked with dark shapes nobody can identify, possibly crackling with lightning nobody can photograph, glowing faintly on its night side, and carrying, in its temperate layer, a contested chemical hint that has never been ruled out. That is not a well-understood planet. That is a mystery in a bright disguise, parked next door, close enough to see from your garden. And now, having looked at what Venus is, we have to ask the question this entire story has been building toward. Not what it is like. Why it is like this. Because remember where we started. Same size, same rock, same iron, the same distance near enough from the same star, and the same birth at the same moment, out of the same cloud of material. Two nearly identical planets, with the same ingredients and the same beginning, and opposite endings. So let's treat this as what it's genuinely been for the last half-century, an investigation. Something happened to this world. We have a body, we have evidence, and we have a suspect. How does a twin of Earth go this wrong? And the first thing any investigation needs is a starting fact. So here is ours, and it is the most important measurement in this entire story. Venus used to have water. We can say that with real confidence. And the reason we can is a piece of forensic chemistry so elegant that it deserves to be walked through slowly. Water is not a single substance. Ordinary water is made with ordinary hydrogen, whose nucleus is one proton. But a small fraction of hydrogen in the universe is heavy hydrogen, called deuterium, carrying a neutron alongside the proton. It behaves chemically the same. It just weighs about twice as much. So every ocean contains a mixture, mostly ordinary water, and a tiny, consistent, measurable fraction of heavy water. Now, when water vapor rises high into an atmosphere and gets split apart by ultraviolet sunlight, the freed hydrogen atoms can escape into space if the planet's gravity can't hold them. And here is the crucial part. The light ones escape more easily than the heavy ones. Ordinary hydrogen leaves faster, and deuterium lags behind, which means that a planet steadily losing its water to space becomes progressively enriched in heavy hydrogen. The ratio of deuterium to ordinary hydrogen creeps upward, and that ratio is a fingerprint. It is a record of how much water has been lost. When spacecraft measured that ratio in the traces of water vapor still present in the atmosphere of Venus, the number came back at roughly 150 times the Earth's value. That is not a rounding error. That is a planet that has been bleeding water into space for a very long time, and the enrichment left behind in what remains is the evidence. There is a second line of evidence that makes the same case from the opposite direction, and I like it because it is so simple. Take all the nitrogen in the atmosphere of Venus. As a proportion, the air there is only about 3.5% nitrogen, which sounds trivially small against all that carbon dioxide. But that atmosphere is enormously massive, roughly 90 times the mass of ours, so 3.5% of it's a great deal of gas. In absolute terms, Venus carries several times more nitrogen than the entire Earth's atmosphere contains, which tells you the planet was not born deficient. It was not skipped over during the formation of the solar system. It received a full share of volatile material, the same delivery of gases and ices and water that built our own air and oceans. It got all the ingredients, and then it simply lost the water. Now, how much water? The honest answer is that estimates vary, and I will not pretend to a precision we do not have. But the models that fit the deuterium evidence generally point to a young Venus holding a substantial quantity of surface water. In some reconstructions, enough to cover the planet in a global layer meters deep. In others, considerably more, potentially a shallow ocean covering much of the world for a long stretch of its early history. There is a reasonable case, argued in serious climate modeling, that Venus may have been habitable for a very long time, possibly for 2 or 3 billion years, possibly longer than the span in which complex life has existed on Earth. Hold that idea for a moment, because it changes the emotional shape of everything else in this story. For a large fraction of the history of this solar system, there may have been 2 blue worlds sitting side by side. 2 planets with liquid water and mild temperatures and thick weather. And a visitor arriving in that era, looking at the pair of them, might well have picked the wrong one to bet on. So the question sharpens. Not merely what Venus is now, but what destroyed it. The mechanism has a name, and it is one of the most important ideas in planetary science. It is called a runaway greenhouse. And the reason it matters is that it is not a slow decline. It is a trap with a door that closes. Here is how it works, and I am going to walk it one step at a time. Because the logic of it's the single most consequential piece of physics in this entire story. Water vapor is a greenhouse gas. That is the starting point. And it's worth pausing on, because people tend to think of carbon dioxide as the greenhouse gas, and forget that plain water vapor in the air traps heat extremely effectively. Now imagine a world with oceans that get slightly warmer. Warmer oceans evaporate a little faster. More water vapor enters the air. Water vapor traps heat. So the world gets warmer still, which evaporates more ocean, which traps more heat. On Earth, that loop is stable. It runs, and then it stops, because our clouds and our rainfall and our temperature range conspire to close it off. Water condenses, falls, and returns. The loop has a break, but push the temperature past a certain threshold and the break fails. Past that point, every additional degree of warming puts more water into the air than the planet can rain back out, and the feedback becomes self-sustaining. It no longer needs the original push. It runs on its own, and it does not stop until there is nothing left to evaporate. That is the runaway. And on Venus, it ran to completion. The oceans did not gradually shrink. They went into the sky. All of it, becoming a colossal global blanket of steam. And steam is such an effective greenhouse gas that surface temperatures during that phase would have soared far above anything we see today, hot enough to soften and partly melt the surface itself. And then, high above, that steam met sunlight, and sunlight broke the water molecules apart, and the freed hydrogen escaped to space, which is the crucial detail, and the reason this is permanent. When Venus lost its oceans, it did not put them somewhere. It did not freeze them into ice caps or bury them underground as a reserve that might someday return. The hydrogen left the planet. It is gone, dispersed into the solar system and beyond, and it is not coming back. You can, in principle, thaw a frozen world. You cannot recover an ocean that has blown away between the stars. Now, what pushed Venus over that threshold in the first place? And here the answer is nothing dramatic at all, which is precisely what makes it disturbing. The The sun did it, simply by aging. Stars brighten as they get older. Our sun has been growing steadily, more luminous throughout its life. By a few percent every billion years, patiently. And it has never once paused. The young sun was noticeably fainter than the one shining today. So picture the situation. Young Venus, closer in than us, holding its water, sitting in a climate that worked. And a star that gets slowly, imperceptibly brighter, century after century, for hundreds of millions of years, until one day the planet crosses a line that nobody could have marked in advance. There was no catastrophe, no impact, no sudden event to point at. The world simply grew a little warmer, and then a little warmer, and then the feedback took over and did the rest by itself. And once the water was gone, every other door closed behind it. This is the part that turns a disaster into a permanent condition. And it's worth understanding, because it's the difference between a hot planet and a dead one. On Earth, water is the repairman for the planet's thermostat. Rain washes carbon dioxide out of the air, dissolving it and carrying it down to react with rock, locking it away in stone. Plate tectonics then cycles that stone into the interior, and through volcanoes, returns the carbon to the sky over millions of years. Carbon in, carbon out. Forever. With the rate quietly regulated by temperature itself. It is a self-correcting system, and it has kept our planet livable for billions of years across enormous changes in the sun's output. Venus, without water, lost all of it. No rain to scrub the sky. Very likely no plate tectonics operating on a dry, stiffened crust. Every molecule of carbon dioxide that its volcanoes ever exhaled simply stayed in the atmosphere, accumulating century after century, with no mechanism anywhere on the planet capable of removing it. That is where the 92 atmospheres came from. Not from some exotic origin. That crushing ocean of gas is the accumulated volcanic exhalation of a planet that lost its ability to clean its own air. And here is the comparison that makes it land. Earth has roughly the same total amount of carbon as Venus. We are not carbon poor by comparison. The difference is where it lives. Almost all of our carbon is locked inside rock, in limestone and chalk, and the bodies of ancient sea creatures compressed into stone, buried by water and time. If you took all the carbon currently stored in Earth's rocks and released it into our atmosphere, you'd get an atmosphere very much like the one on Venus. The difference between the two planets is not the ingredients. It's that one of them keeps its carbon filed away in the ground, and the other has it all in the air. And the thing that did the filing was water. Same materials, different storage. One world got a window, and one got a lid. Now, before we leave the mechanism, there's a final irony buried in the science, and it closes a circle we opened at the very beginning of this story. The runaway greenhouse of Venus was not simply discovered by climate science. In a real sense, it helped found it. The idea that atmospheric gases can warm a planet goes back to the 1820s and the French physicist Joseph Fourier, who wondered why the Earth was warmer than sunlight alone should make it. And the first person ever to sit down and calculate what changing the amount of carbon dioxide would do to the temperature of the Earth, working through a year of tedious hand arithmetic in the 1890s, was Svante Arrhenius, the same Arrhenius. The Nobel laureate, who dreamed of dripping Venusian swamps, was also the man who first computed the power of carbon dioxide over a planet's thermostat. He held both halves of the answer in one mind. The world with the runaway greenhouse, and the physics of the greenhouse itself. And he never connected them. 2 generations later, the researchers who proved the furnace real carried the lesson in the other direction. One of the scientists who spent his early career modelling the clouds and heat balance of Venus, James Hansen, went on to become one of the most consequential voices in the study of Earth's own changing climate. That isn't a coincidence, it's an apprenticeship. Venus is where our species first watched a greenhouse effect run to its logical conclusion at planetary scale, with no politics attached and nowhere to hide. The evening star turned out to be a textbook. The subject was planetary thermostats, and what happens to worlds that lose them. And the portrait holds one more panel, the one that faces us. The sun has not finished brightening. The same slow stellar warming that pushed young Venus over its edge is still underway, a few percent every billion years, patient and unstoppable. Earth stands next in line. I want to be careful and accurate here, because this is exactly the sort of fact that gets distorted. The timescale is enormous. The models that examine this generally place the end of Earth's habitability somewhere on the order of 1 billion years or more into the future. And the mechanism is our own sun's brightening, not anything happening in a human lifetime. Nothing about Venus tells us that Earth is about to become Venus. What Venus tells us is smaller and stranger, and I think more interesting. It tells us that the habitable state of a planet is not a permanent property of that planet. It is a phase. Worlds pass through it, and they can pass out of it. And the exit is not always gradual, because feedback loops do not negotiate. We are not looking at our fate when we look at that light. We are looking at a demonstration of how a thermostat fails. Now, that is the atmosphere accounted for. But the ground has one more chapter, and it's the newest part of this whole story, because it was discovered while I could reasonably say we were all alive to see it. When the radar maps came back, scientists counted the craters of Venus and found something that did not fit. There are roughly 1,000 impact craters on the entire planet, and they are distributed almost randomly and, crucially, the surface everywhere is about the same age, a few 100 million years. There is no ancient ground on Venus, no heavily battered highlands like the Moon's, no preserved record of the early solar system, nothing older than roughly the last 20% of the planet's history. Something wiped the face of that planet clean, and it did so comparatively recently. One leading interpretation is as dramatic as it sounds. Venus, unable to release its internal heat steadily the way Earth does through plate tectonics, may instead store that heat until the entire crust fails at once, resurfacing the whole planet in global floods of lava, perhaps every few 100 million years. In that picture, even the ground of Venus is temporary. A world that periodically erases itself. For 30 years, that idea remained a story about the deep past, argued from crater statistics. Then, in 2023, the past sat up and moved. A planetary scientist named Robert Herrick attempted something most of his colleagues considered close to hopeless. He began combing by eye through the 30-year-old Magellan radar images, hunting for any patch of ground that had visibly changed between the spacecraft's mapping passes in 1991. Consider those odds. The planet has a surface area of roughly 460 million square kilometers. The radar images are grainy. Different passes viewed the same ground from different angles. So most apparent differences are just geometry. And he was looking for a change that might span a couple of kilometers. He concentrated on the regions where fresh activity seemed most plausible. And after months of searching, on the flank of the planet's tallest volcano, he found one. The volcano is Mat Mons, named for the Egyptian goddess of truth and justice, a mountain rising roughly 8 kilometers above the plains. In an image from February of 1991, one of its vents appears as a neat deep pit covering about 2 square kilometers. In an image of the same vent taken in October of that year, 8 months later, the pit has roughly doubled in area. Its walls have slumped. It appears filled nearly to the rim, and the ground downhill shows what looks like fresh flow material that was not there before. The straightforward reading is the remarkable one. A volcano on Venus erupted while a human spacecraft happened to be looking at it, and then the evidence sat unexamined in an archive for 30 years, waiting for one stubborn person to look closely enough. Since then, Other researchers combing the same old data have reported further slopes that appear to have brightened with new rock between passes. So the verdict changes. The crater counts told us about the ancient past. This is not the ancient past. Venus is very likely a volcanically active world right now, and we learned it not from a new mission but from old photographs examined with fresh patience. And once you know the fire is lit, the scale of the place comes into focus. A recent census of the volcanic features visible in the Magellan maps catalogued roughly 85,000 volcanoes. 85,000. And that includes only the ones large enough for 30-year-old radar to resolve, so the true count, including smaller cones, is presumed to run far higher. Venus is the most volcano-crowded surface we have ever mapped. Yet that same investigation revealed something else, a strange mercy hidden inside the deadly air, and I want to end the geology on it because it may be the only defensive gift this planet offers. Remember that Venus has only about 1,000 craters. Compare that with the Moon, which carries millions upon millions down to pits the size of a thimble, because the Moon has no protection whatsoever. And on Venus, the small craters are not merely rare. They are absent. There is essentially nothing below about 2 kilometers across, no small dents, no fine shrapnel scarring of the kind that covers every other rocky world. The reason is the atmosphere, an incoming stone the size of a house, the kind that punches a tidy crater into the Moon, hits the top of that 92-atmosphere ocean and is simply eaten, shattered and vaporized long before it can reach the ground. Only genuinely large asteroids carry enough momentum to force their way through. So hold both truths about that air at once. It's the single most lethal feature of any planetary surface in the solar system, and it's also the finest meteor shield a rocky world has ever worn. The sky that would crush you protects the ground that would burn you. Nothing on this planet is only one thing. Even its armor is made from the same material as its weapon. And now we come to the thing this whole journey has been building toward. Let's take everything we've gathered and translate it out of the language of planetary science into the language of an ordinary day. Because that is what the question actually means. Not what is Venus like? What would it cost you to live there? Begin with the simplest human act imaginable. Going outside. On Earth, stepping out of your door is free. It costs nothing, it requires no equipment, and it is so unremarkable that we do it without registering it as a decision at all. On the surface of Venus, going outside is not difficult. It is not dangerous. It is impossible. And the distinction matters. Think about what a surface suit would have to be. It can't be a pressure garment, because the pressure outside is 92 atmospheres, and a flexible fabric holding back that difference isn't a suit, it's a hull. It cannot rely on ordinary cooling, because there is nowhere for the heat to go. On Earth and in space, you shed heat by radiating it away or dumping it into something colder. On Venus, everything in every direction is at 870 degrees. There is no cold sink anywhere on that planet. A cooling system needs somewhere to put the heat, and the entire world is hotter than the thing you are trying to cool. So a Venus surface suit is not clothing. It's a rigid, actively refrigerated deep-sea vessel with a person inside, carrying its own heat rejection system that has nothing to reject into, walking around on a plane where our best unmanned machines have never lasted longer than about 2 hours. And remember that those machines were not carrying a human being, or the water and food and cooling and shielding a human being requires. They were simple, rugged, sealed instruments, and the planet killed all of them on a clock. Now think about power, because everything else depends on it. The obvious answer for a hot, bright inner planet is solar. And on the surface of Venus, solar power is poor. Only a fraction of the sunlight makes it down through 50 kilometers of cloud, and what arrives is diffuse. And then the deeper problem, which is that the panels, the wiring, the batteries, and the electronics are all sitting in an oven that will destroy them, Ordinary semiconductors do not function at these temperatures. The entire basis of our electronics simply stops working. Engineers have made real progress on this, and it is genuinely impressive. There is serious work on high-temperature silicon carbide electronics designed to run at Venus surface conditions without any cooling at all, and prototypes have survived simulated Venus environments for weeks. That is a remarkable achievement, and it may well produce a long-lived surface station one day. But note what that is. It is a strategy for building a machine that can sit in a furnace and keep reporting. It is not a strategy for keeping a person alive in one. Now think about food. Nothing grows on the surface of Venus. There is no soil chemistry that plants can use, no liquid water, no photosynthetic light, and temperatures that would carbonize any organic material in seconds. Every calorie ever consumed on that surface would have to be manufactured somewhere else and delivered. Think about water, of which there is essentially none. The planet has been dry for something like 1 billion years, and the only water anywhere in the system is the trace vapor and the acid droplets high in the atmosphere, tens of kilometers above your head. Think about repair. Every seal, every joint, every window, every wire on any surface installation is being attacked continuously by heat, by supercritical carbon dioxide that dissolves and permeates in ways ordinary gases don't, and by trace corrosive gases in the air. There is no maintenance-free interval. The environment is always winning, everywhere, at every point of contact, permanently. And now, add the final weight, the one that makes all of this heavier than any settlement humans have ever attempted. And there's no rescue. Venus is close as planets go. But a crew in trouble on that surface is not somewhere you can reach in an emergency. And more than that, there is nowhere to retreat to. On Mars, a failed habitat leaves you in a cold, thin desert with your suit still working. On the Moon, the same. On the surface of Venus, a hull breach is not an emergency to be managed. It is instantaneous and total. So here's the honest answer to our question, at least where the ground is concerned. Living on the surface of Venus is not a hard version of living somewhere else. It is not Mars with the difficulty raised. Every single method our species has ever developed for surviving a hostile environment fails there simultaneously. Pressure vessels, cooling, power, agriculture, water extraction, materials, communication, rescue. Would living there be worse than you'd imagine? On that surface, the question stops being a comparison at all. It isn't worse than you think. It's worse than you can think. Because your mind reaches for some familiar hardship to scale up. And on Venus, there simply isn't one to reach for. And that is where nearly every account of this planet stops. Verdict delivered. Case closed. A beautiful light hiding an impossible world. But we are not going to stop there, because if you go up, everything changes. Now, I want to be careful with what follows, because it sounds at first like a consolation prize invented to end the story on a pleasant note. And it's not that. It is a serious proposal, seriously argued, and the numbers behind it are better than almost anyone expects. Leave the surface. Rise up through that amber murk. 10 kilometers, 20-30. The pressure falls away. The temperature drops. The crushing supercritical fluid thins back into ordinary gas. At about 50 kilometers above the ground, something remarkable happens. The pressure outside is roughly 1 atmosphere. The same as the room you are in right now. The temperature is somewhere in the range of 0 to 60 degrees Celsius, depending on the exact altitude. Which is to say, at the right height, it is room temperature. Shirt sleeves. The temperature of a warm afternoon. The gravity is about 90% of Earth's. Because you have barely left a planet that is almost exactly our size. And the radiation environment is comfortable, because you've 50 kilometers of dense atmosphere below you, and a good deal of it above you as well, giving a shielding mass column comparable to standing at sea level on Earth. Now stop and take in what that combination means. because there is nothing else like it anywhere. Earth normal pressure, room temperature, near-Earth gravity, and Earth-comparable radiation shielding. All four at once, together, in one place, and that place is 50 kilometers above the deadliest surface in the solar system. There is no other location in the solar system, beyond our own planet, where all four of those conditions are met simultaneously. Not on Mars, not on the Moon, not on any moon of Jupiter or Saturn, nowhere. The most Earth-like environment in the solar system, other than Earth, is in the sky of Venus. And now comes the piece of physics that turns a curiosity into an engineering proposal, and it is my favorite counterintuitive fact in this entire subject. The atmosphere of Venus is carbon dioxide, which is a heavy gas. Ordinary breathable air, the everyday nitrogen and oxygen mixture filling the room around you, is much lighter by comparison, which means that on Venus, breathable air floats. A sealed envelope filled with nothing but ordinary air will rise through the atmosphere of Venus, the way a helium balloon rises through the air on Earth. The lifting gas is the atmosphere of a human habitat. Think about what that does to the engineering problem. On Earth, an airship needs a bag of helium and then a separate gondola hanging underneath for the people. On Venus, you do not need the separation. The habitat is the balloon. The volume the crew lives in is the same volume that holds it up. And the lift is substantial. A sphere of ordinary breathable air, roughly the size of a large building, would support a considerable mass of structure and equipment at that altitude. There is a second gift here too, and it is a safety one that most people miss. Because the pressure inside your habitat and the pressure outside are essentially the same, a puncture is not an explosive decompression. There is no violent pressure difference driving your air out. A hole in a floating Venus habitat leaks slowly, mixing at a rate you have hours or longer to deal with, rather than seconds. Now compare that with the alternative we have all collectively agreed to dream about. On Mars, the outside pressure is well under 1% of Earth's, so every structure is a pressure vessel and every breach is a catastrophe. The gravity is about 38% of Earth's, with entirely unknown long-term consequences for human bodies and completely unknown consequences for children. There is no meaningful atmospheric shielding, so the radiation problem is permanent and requires burying yourself under regolith. The temperature is brutally cold, and the trip is long. At Venusian cloud altitude, the pressure is Earth normal, the temperature is mild, the gravity is 9/10 of ours, and the radiation shielding is already there. That comparison is the quiet scandal of space settlement, and it deserves to be stated plainly. On the raw environmental numbers, the sky of Venus beats the surface of Mars on nearly every axis that matters to a human body. This is not a fantasy I have invented for the ending. It has flown in a limited way, and it flew a long time ago. In 1985, the Soviet Union, in its final great planetary campaign, sent 2 missions called Vega toward Halley's Comet, and had them drop payloads at Venus along the way. Each released not only a lander but a balloon, which inflated in the cloud layer at roughly 54 kilometers and floated free. Those 2 balloons sailed in the atmosphere of Venus for about 46 hours each, carried by the super-rotating winds, transmitting continuously before their batteries ran out. They traveled roughly a third of the way around the planet. Humanity has already flown machines in the habitable layer of Venus, and they worked exactly as intended 4 decades ago. The modern version of the idea has been studied at NASA under the name HAVOC, the High Altitude Venus Operational Concept, and the architecture is roughly what you'd expect. An airship arrives folded, inflates during descent, and stabilizes in the cloud layer. Crews live aboard. Solar power is abundant, both from direct sunlight above the deck and from light reflected off the bright cloud below, so the panels collect from both sides. And the materials problem, which sounds like the hard part, is genuinely not the hard part. Sulfuric acid is aggressive, but it is a known industrial substance. And there are common fluoropolymer coatings and acid-resistant fabrics that handle it well. This is a solved chemistry problem wearing a frightening name. What about supplies? Here is the elegant part. Nearly everything you need is in the air around you. Carbon dioxide can be split into carbon and oxygen, giving you breathable air and structural material. Water is present in trace vapor and in the acid droplets themselves. And the sulfuric acid can be processed to yield water. Nitrogen for buffer gas is right there in the atmosphere as well. The planet that destroys everything on its floor turns out to be, at altitude, almost absurdly generous with raw materials. Your world drifts, and everything you need is dissolved in the sky around you. And think about the people, because the human details are where this idea quietly wins. A child born on a floating Venus city would grow up in 90% of Earth's gravity. Close enough that their bones and heart and eyes would very likely develop normally, which is something nobody can promise about a child raised in the reduced pool of Mars or the Moon. Of every proposed home beyond this planet, the clouds of Venus are the only one where a human body, tuned by 4 billion years of Earth gravity, would feel nearly at home. Their windows would face weather rather than vacuum, and the psychologists who study long-duration missions consider that no small thing. A view that moves, clouds that build and change, light that shifts. Mars offers a still red desert. The Venusian sky offers an endless golden sea, sliding past at the pace of those enormous winds. And at night, on the dark side crossing, the crew could do the one thing nobody on the surface below them could ever have done. They could go up to an observation deck above the haze, where the sky finally clears, and look out at the universe. And they would find, hanging among all the other lights, a brilliant blue-white point rising ahead of their strange western dawn. Home, playing the role of the evening star. Some of them, the ones born aloft, would know Earth only as that, the brightest light in their sky, a place their parents described the way people describe childhood houses, warmly and less often. The journey itself is kinder too, and this is the last practical advantage. Launch windows to Venus open every 19 months, more often than windows to Mars. The crossing takes roughly 3 to 4 months with current propulsion, a fraction of a Mars transit, which means less radiation absorbed on the way, less food, less muscle lost, less time for machines to fail and minds to fray. And if something goes wrong, the orbital mechanics of an inward journey offer faster returns than the long outward road to Mars, where a crew in trouble must simply wait for the planets to permit a rescue. Venus is the closest world, with the gentlest sky, reached by the shortest road, on the most frequent schedule. Now, I have made the case as strongly as it deserves. So, let me be equally honest about the other side, because I don't want to hand you a fantasy after spending an hour dismantling one. There is nothing to stand on, ever. That is not a detail. Every human settlement in history, including every proposed one on any other world, rests on ground. A floating city has no ground, no foundation, no anchor, and no possibility of stopping. It's a ship on an ocean with no shore and no bottom, and it must remain aloft continuously, forever, because there's no such thing as landing. Every gram of mass must be lifted and kept lifted. Every repair happens in flight. Any structural failure serious enough to lose buoyancy drops the habitat toward a surface that will destroy it long before it arrives, and there's no rescue and no salvage. And the resources of Venus are in its air, not its ground. There is no mining. There are no metals, no ores, no rock. Nothing to build with that's not either brought from elsewhere or extracted molecule by molecule out of an acid sky. A cloud colony would be permanently dependent on chemistry rather than geology, and that is a much thinner margin. So the honest verdict is not that the clouds of Venus are easy. It is this. The surface of Venus is the single most hostile place a human being could attempt to stand in the entire solar system, and 50 kilometers above, It's the most comfortable place a human being could attempt to float in the entire solar system. And both of those statements are about the same planet at the same moment, separated by less distance than many people commute in a week. Before we finish, there are two more things worth putting on the table, because both of them are about what happens next rather than what happened already. The first is the question that every hostile world eventually attracts. Could Venus be repaired? The proposals exist, and they are magnificent, and each one dies on the same altar. To cool the planet, you could build a sunshade at the gravitational balance point between Venus and the Sun, a parasol thousands of kilometers across, and let the furnace cool in its shadow. The construction would dwarf every object humanity has ever built, combined, many times over. And the cooling alone would take centuries before the first meaningful improvement was felt. To remove the ocean of carbon dioxide, you could freeze it out over ages into seas of dry ice and bury it, or bind it chemically into rock, and the quantity involved is a layer of gas 90 times more massive than our entire atmosphere. Every proposal for processing it is an industrial operation on a scale that has no precedent in anything our species has ever done. And then, at the end of all of it, you'd have a cool, dry, airless, waterless planet, still turning backwards with a day longer than its year, and no ocean to give it, because the ocean it once had left permanently for interstellar space and there's nothing to recover. So terraforming Venus is not simply hard. It's a project to build a world from scratch, using a dead one as a foundation, and the honest reckoning is that floating a city in the clouds is easier than fixing the ground beneath it by a margin so large that the comparison is almost silly. The second thing is happier, because after a long, quiet period, we are going back. For decades, Venus was neglected. Mission after mission went to Mars while the nearest planet sat unvisited, largely because it is a difficult place to work, and the results come slowly. That has changed. A small fleet is now being prepared. An American probe called Da Vinci is planned to plunge through the full depth of that atmosphere, sampling it layer by layer on the way down, and photographing the surface as it descends, the first direct atmospheric descent in more than 40 years. An orbiter called Veritas and a European mission called Envision are intended to map the surface through the clouds in radar detail fine enough to catch the planet in the act and to finally settle whether its volcanoes still erupt, whether its crust still moves, and whether the great resurfacing is history or prophecy. And that descent, when it comes, will be a strange homecoming for this whole story. Picture its final hour. Released from its carrier, the probe strikes the top of the atmosphere and slows violently. It falls through the acid deck, sampling as it goes, tasting the gases that no instrument has measured properly since the Venera era, looking for the isotopes that would settle the question of the lost ocean once and for all. It passes the temperate layer where cities might someday float. It descends into the amber murk, and the pressure climbs, and the heat climbs, and it keeps reporting. And in its final minutes, it will photograph the ground of Venus in the visible light of that permanently overcast sky for the first time since the 1980s. It is not expected to survive the landing. Nothing is expected to survive there. That is not a design failure. That is the planet. So let's take the whole world in one slow descent, top to bottom, and watch the question we started with change its answer as we fall. At the cloud tops, 60 kilometers up, Venus is beautiful and lethal at the same time. A racing golden sea where the sunlight is doubled by reflection and dark, unexplained shapes drift through the ultraviolet. In the clouds themselves, around 50 kilometers, comes the exception. Earth pressure, room temperature, 9/10 of our gravity, breathable air that floats. The one place beyond this planet where a human body would feel nearly at home, there. And only there. The honest answer to the question is no. It would be hard and strange, and it would also be the most livable sky anywhere off Earth. Below that, the answer begins to burn. At 30 kilometers, the eternal rain boils away in the rising heat. At 20, the pressure passes anything a submarine has survived. And at the bottom, on the amber plains where the Venera landers still stand beside their lens caps in supercritical air, under a lid that has never once shown a star, at 870 degrees in every direction forever, the answer stops being a comparison at all. So that's the whole of it, top to bottom. And now that we've been all the way down and all the way back up, let's just sit with what it actually means. We began with a promise. The nearest planet, almost exactly our size, made from the same materials, formed at the same time, warmed by the same star, and called our twin for 300 years. And the twin turned out to be the most hostile surface in the solar system. That is the thing worth carrying away from this. Not the temperature, remarkable as it is, not the pressure, or the acid, or the backwards clock. It is the divergence itself. Two planets, built side by side, out of the same cloud, in the same hour, from the same rock and the same iron and the same delivery of water. One of them kept its oceans, and its oceans filed its carbon away into stone. And the thermostat held, and the world stayed mild long enough for something to crawl out of the water and eventually look up and wonder about the light next door. The other lost one repair mechanism, just one, water and everything water does, and with it went the rain that scrubs the sky, and the rock cycle that buries the carbon, and the break on the feedback loop. And then the oceans themselves climbed into the air, came apart in the sunlight, and blew away between the stars. Nothing about that outcome was written in advance. The ingredients were nearly identical. The results could hardly be further apart. Venus is what Earth looks like, with a single system removed. That is the quiet weight this evening's star has carried ever since we learned to read it. It is not merely another world, it is the control experiment. The universe ran our planet twice, side by side, under slightly different conditions, and one version became every home you've ever known, and the other became the brightest light in our sky. And yet the story refuses to end as a tragedy, because of that one impossible kindness 50 kilometers up. From a floating city in the clouds of Venus, Earth would be exactly what Venus is to us, the brightest light in the sky, a calm, steady, brilliant point above the horizon, rising ahead of a strange western dawn. Two twins, still facing each other across the dark, one wrapped in acid, one wrapped in water, each one the evening star of the other. The universe closed an entire world and left one window open in its sky. So the next clear evening, when that light comes out above the horizon, look at it with honest eyes. It is not a wishing star. It was never a twin. It is a furnace wearing a veil, and a warning written in sunlight, and, drifting somewhere inside those clouds, the gentlest sky beyond Earth, all three at once, hanging above your rooftops. So let the whole journey settle now, and drift back one last time over everything we found down there. Tonight you stood on a world where the ground melts lead and the night lasts 2 months and changes nothing at all. You dove through an ocean of sky to reach it. 900 meters of pressure. And you heard another planet's wind breathe through a dead lander's microphone. You watched rain fall for 100 million years without ever landing. You saw a clock so broken that the year ends before the day does, and a sunrise that comes up backwards in the west after 2 months of dark. You traced a whole ocean as it climbed into the sky, came apart in the sunlight, and blew away between the stars. And you watched the world left behind bury itself under its own breath. And then, 50 kilometers above all of it, you found the one gentle thing this planet still keeps. A layer of sky where the numbers all come out kind. Where ordinary breathable air is a flying machine. Where 2 Soviet balloons once sailed for days. And where someday, perhaps, cities might drift on the 4-day winds with their windows glowing and their gardens breathing. and children who were born up there might look through the golden clouds at a bright blue evening star and call it Earth. That's the last turn of the veil, and it's the one worth carrying into sleep. The universe closed an entire world, and then left a single window open in its sky. Now, there's nothing here you need to hold on to. No quiz waiting at the end of the solar system, no facts to keep. Let all of it settle out of your mind, the way that metal frost settles onto those amber mountains. Slowly, quietly, and without anyone watching. Let your shoulders soften. Let your breathing find its own easy rhythm. The most beautiful light in your evening sky is the worst place a person could ever stand, and the kindest sky a person could ever sail. And both of those things are rising quietly over your horizon tonight while you rest. If you're still awake, and you'd like one more journey, there'll be another one waiting on the screen to carry you onward. Otherwise, just stay here in the quiet. The stars will keep spinning while you sleep. Good night.